Laboratory is a facility that provides controlled conditions in which scientific or technological research, experiments, and measurement may be performed. Laboratory services are provided in a variety of settings. It could be a physician's office, clinics, hospitals, and regional and national referral centers, or, in your case, in laboratory rooms where experimentation for organic chemistry occur. But laboratory experiments is sometimes hazardous and may lead to harm if not done right. That is why proper laboratory techniques must be observed at all times. Laboratory techniques are the set of procedure used on natural sciences such as chemistry, biology, physics to conduct an experiment. All of them follow the scientific method. While some of them involve the use of complex laboratory experiments from laboratory glassware to electrical devices and others, require more specific or expensive supplies. Organic chemistry experiments involve many reactions to carry out a desired product that can be measured or weighed. These are a procedure that contain a single or combined practice of mixing, transferring, heating, or cooling to a certain temperature. The main goal is to purify the crude product and obtain the specific purified compound or chemical. These will require specific operations depending on the nature and properties of this product, depending on the different physicochemical properties of the components of a mixture. For these activities or objectives to be realized, basic laboratory techniques and operations such as separating components of a mixture like sublimation, extraction, decantation, filtration, and evaporation will be performed, or it could be through purification of organic compounds such as distillation and heating under reflux, and sublimation can also be used. Thus, sublimation can be used for separating mixture and purification process. In this discussion, we will know these techniques one by one. First, we have sublimation. Sublimation involves heating a solid until it passes directly from the solid phase into the gaseous phase. Sublimation refers to a physical change of state, and it's not used to describe the transformation of a solid to a gas in a chemical reaction. For example, the dissociation of heating of solid ammonium chloride into hydrogen chloride and ammonia is not sublimation but a chemical reaction. Similarly, the combustion of candles containing paraffin wax to carbon dioxide and water vapor is not sublimation but a chemical reaction with oxygen. You have to understand that sublimation is simply the transition of a compound from solid state to a gaseous state. Thus, there should be no chemical reaction involved. Materials needed for this setup are funnel, cotton, evaporating dish, wire gauze, tripod. If you don't have tripod, you can use hot plate, and Bunsen burner. How to do this? First, you have to spread the crude, dry, solid to be sublimed in an evaporating dish. Place the evaporating dish supported by a wire gauze on a tripod. The purpose of using wire gauze in this setup is to spread evenly the heat all over the entire evaporating dish. Next is you have to cover the evaporating dish using an inverted funnel, just like here in our picture. Next is you have to plug the apex or the ending of the funnel using the cotton. Lastly, you have to place and light the Bunsen burner below the tripod. This Bunsen burner here will be our source of heat. What will happen here is that the crude product containing mixture of volatile components from non-volatile components is extensively separated. To further understand this, you have to know that volatile components are substances that are easily evaporated at normal temperatures, like the chemical benzene, ether, or hexane. This means that under the sublimation technique, the two mixture of volatile with the non-volatile are subjected to a certain temperature and reduced pressure. The volatile compound will be evaporated as gaseous state. As you can see here, since the two mixture is subjected now to a certain temperature, the volatile product will now become a gaseous state or a vapor, leaving the non-volatile compound in the evaporating dish. The volatile compound that was evaporated and become a gas has to stay in the setup, and to prevent them from living in this setup, we use the cotton to trap it in the funnel. Since in the setup, the area in the funnel is much cooler to the area in the evaporating dish, the volatile compounds will go back to its solid state. As you can see here, we have the volatile compound here in the side of the funnel as solidified compound. We call this process as deposition, or a gaseous state become solid and will remain now in the side of the funnel. This purified volatile compound is what we call the sublimate. Again, this solid compound here that was formed after evaporation and subjected to deposition is what we call sublimate. Another technique we have here for the separation of mixture is extraction. Extraction uses a solvent to selectively dissolve one or more components from a liquid mixture. It is used to purify compounds or to separate mixtures of compounds, such as when isolating a product from a reaction mixture, or also known as extractive workup. Extractive workup simply means that the two products was immiscibly combined together because one solvent will react to one of the compounds in the mixture. Material needed are the following. We have funnel, separatory funnel, iron stand, iron ring, clamp holder, and receiving container like a flask or a beaker. To do this technique, first you have to place a separatory funnel in an iron ring supported by a clamp holder with its iron stand. There are some iron ring in which the end has a screw that can be clamped in the iron stand directly, just like in our picture, so no need to use the clamp holder. Next is you have to put the liquid mixture inside the separatory funnel by removing the stopper above. There is a stopper here that is to cover the separatory funnel, so you have to remove it first. And using the funnel here, you have to guide the flow of the liquid mixture to go inside in the separatory funnel. And then afterwards, if all of the mixture was now in the separatory funnel, you have to remove again the funnel and cover the separatory funnel with the stopper. Make sure also that the stopcock here is closed to prevent the liquid to spill. The next step is you have to get the separatory funnel to the setup and mix the liquid by shaking the separatory funnel gently in an up and down motion. Never forget to hold the stopper while mixing because there are some instances that this stopper will be removed when you shake it. And then put back the separatory funnel in the setup, then wait for the liquids to be separated by forming layers. If there is now a layer, as you can see in the picture, there is a top layer and a bottom layer. Extract now the immiscible liquid separately by manipulating the stopcock plug of the separatory funnel and place each in different designated container. As you can see in the resulting product of extraction, we saw two layers, the top layer and the bottom layer. In extraction, the liquid must be immiscible. This means that they will form two layers when added together, like the oil and water. Some compounds are more soluble in the organic layer like the oil, and some compounds are more soluble in the aqueous layer like the water. Another thing that you need to know, the two liquids to be isolated also have to have different densities. If we have the mixture oil and water, we know that oil is less dense than water, and therefore in this setup, the oil will be the top layer while the water will be the lower layer. Another technique to separate the mixture of compounds is decantation. If extraction is the mixture of two immiscible liquids, decantation separates a liquid from an insoluble solid sediment by carefully pouring the liquid from the solid without disturbing the solid. It is used to purify a liquid by separating it from a suspension of insoluble particles. Materials needed are simply beaker and stirring rod. To do this, you have to separate the liquid by placing the stirring rod on the pouring mount of the beaker and pour the liquid to another beaker, just like in our picture. The stirring rod is used instead of directly pouring the mixture to guide the flow of the liquid without disturbing the insoluble solid. When doing the decantation, do not allow the solid particles to be poured in, only the liquid. The liquid product we have separated is what we call the supernatant. This one and this one is what we call the supernatant. And the insoluble solid is what we call the sediment, or other reference, they call this one as precipitate. Filtration has the same objective with decantation, as it separates a solid from a liquid. Only that it has a barrier in separation, which is the filter paper. This is more accurate compared with decantation, as the solid particles remain in the filter paper. Materials needed are beaker, funnel, filter paper, iron ring, iron stand, and receiving container, or we can have the flask or beaker. To do this, you can use a tripod or an iron ring to hold the glass funnel above. Below the funnel, you have to place the container for the filtration. Next is place a filter paper fitted in the cone of the funnel. Then, pour the mixture from the beaker to the funnel carefully. You can use the stirring rod to guide the flow of the liquid, just like in the decantation. Then, wait for the mixture to be filtered before pouring the remaining parts. The liquid that can be filtered is what we call filtrate, while the solid that remains in the filter paper is what we call residue. So, relating this one in the decantation, the liquid is supernatant. But if it's filtration, the liquid will be filtrate. Relating also the solid particles in the decantation, we call that one as sediment or precipitate, while in the filtration, we call that one as residue. The last example of separating mixture is evaporation. Evaporation is the process of heating a mixture in order to drive it off in the form of vapor, as to make the remaining component dry. It is used to separate a liquid from solid by means of heat transfer via vaporization or boiling. It is used to concentrate a solution of a non-volatile solute. It is somewhat similar with the sublimation, only that in sublimation, what we are after is the vapor, while in the evaporation, what we are after is the remaining components in the evaporating dish. Another difference they have is that in sublimation, the mixture is in solid state. However, in evaporation, the mixture is in liquid state. Materials needed are evaporating dish, wire gauze, tripod, and Bunsen burner. If you don't have a tripod, you can use the hot plate. To do this, place the evaporating dish supported by a tripod with a wire gauze. Again, the wire gauze will be used to evenly distribute the heat in the evaporating dish. And then, place and light the Bunsen burner below the tripod. The resulting solid left in the evaporating dish is what we call precipitate, or also named as solid residue. We are now done to the techniques that separates mixture of compounds. Let's proceed now to purification. The first technique in purification is distillation. Distillation is one of purification method in which a liquid is subjected to a boil. Then the liquid becomes a gas. The gas condenses and returns to liquid state, and the liquid is then collected. It is used to purify or separate liquids based on their different boiling points. It is important to note that distillation is not a chemical reaction, but it can be considered as a physical separation process. Materials are iron stand, iron ring. If without iron ring, you can use hot plate instead of Bunsen burner. Next is clamp holder to support the extension clamp. Next is we have universal or extension clamp, distilling flask, cork stopper, thermometer, wire gauze, Bunsen burner, condenser, rubber tubing, and receiving container or flask or a beaker. And you can also use distillation and condenser adapter, but it is only optional. To do this, you have to fix the iron ring and clamp holder to an iron stand, as you can see here in our setup. Again, if the iron ring have the screw on their ends, no need to use the clamp holder. Next is place the distilling flask containing the mixture supported by a wire gauze on the iron ring. Again, we need to use the wire gauze in order for us to have a evenly distributed heat throughout the process. Next, you have to use the thermometer with the cork or cotton on the top of the distilling flask. It is an important part, though it was not seen in our setup, that thermometer should be used or should be placed here at the top to maintain a certain temperature to avoid the solvent from evaporating, leaving only the solute to be only the product that will be evaporated. Next is fix the clamp holder and the extension or universal clamp to another iron stand in order to secure the condenser. Next is you have to mount the distillation or condenser adapter with a receiving container here where the distillate will be collected. Again, if you don't have the distillation or condenser adapter, it's okay not to use it. Next is you have to connect the rubber tubing to the condenser to provide the water. The inlet from water supply, this one, should be on the lower end, and the outlet to sink or where the water goes out should be on the upper end, just like here. We call these two outlets as the water in and water out. Lastly, heat the distilling flask using a Bunsen burner. What will happen here is that in the distillation, since the temperature in the Florence flask is increases, the substance having the lower boiling point in the mixture will be evaporated, leaving in the Florence flask the higher boiling point substance. It is also crucial to always maintain the temperature to the boiling point of the solute only as to prevent the solvent to be evaporated too. Once the solute will be evaporated and become a gas, it will now go to the condenser. Since in the condenser, the temperature is lowered down because of the continuous flowing of water, the gaseous vapor will back to liquid. We call this process as condensation. So from evaporation, it will now go to the process called condensation. This is also the reason why the apparatus was named as condenser, as it is where the condensation happens once the gas becomes a liquid. Once the gas becomes a liquid, it will now be received in the receiving flask or beaker. The resulting product is what we call distillate. Lastly, heating under reflux. It is used to provide many organic reactions that can take an extended period of time to achieve any noticeable effect in which heating is applied to increase the reaction. Reflux came from Latin word refluxus, or it means a flowing back. It refers to an experimental method that involves heating a reaction mixture to boiling point temperature of the certain solvent and inducing the solvent to recondense back into the reaction flask using a condenser. Reflux under heating is a simple and efficient way to maintain a constant reaction temperature. To prevent evaporation of the liquid, solvent vapors are trapped by the condenser and the concentration of reactants remain constant throughout the process. The main purpose of refluxing a solution is to heat a solution in a controlled manner at a constant temperature. If in the distillation, the solute is what we needed to be evaporated, in the heating under reflux, the solvent should be the one to be evaporated. The materials needed are the following: iron stand, hot plate, universal clamp, condenser, rubber tubing, Florence flask. To do this, first, fix the extension or universal clamp and clamp hold to an iron stand, just like here. Place the round bottom flask containing the mixture supported by wire gauze on the hot plate. Attach the condenser upright, just like here, to the round bottom flask, placing the open end at the top. Adjust the extension or universal clamp and clamp holder. Plug the condenser at the open end with a stopcock or a cotton. You now have to place here a stopcock or a cotton. This is important as to not allow the evaporated solvent to go out in the setup. Next is connect the rubber tubing to the condenser to provide the water. The water inlet supply is on the lower end and the outlet to the sink is above. Heat and boil the round bottom flask using the hot plate. There are a couple of things we need to understand in this technique. First, you bring the temperature to a high value first. So you have to have a high temperature here to a high value first, just to get the solvent from boiling. Then, you lower the temperature to minimum value that will sustain the boiling process, keeping the temperature constant. Once the temperature is lowered down again to the supposed boiling point of the solvent, you increase the temperature again. The main goal here is to keep the boiling point temperature of the solvent constant, so you will just increase and decrease the heat source to maintain it. While doing this technique, you will notice a reflux ring. The formation of a reflux ring is a good way to monitor the rate of heating. An indication that you are about to form a reflux ring is the formation of liquid droplets above the boiling liquid that look like a sweat. You can find it here. There would be a reflux ring that will form here or also here that look like a liquid droplets. As the droplets become more numerous, A well-defined borderline forms where the vapor condenses, resulting in a reflux ring. The ring will not form unless the solvent is boiling at a steady state and not too fast. The point at which the rate of evaporation equals the rate of condensation determines the ideal rate of heating. If the reflux ring reaches halfway up the condenser or higher, the heat should be lowered down to prevent vapors from escaping the flask. And then, afterwards, turn off the heat source and remove the flask from the heat by either lifting the reflux apparatus up or dropping the heat source down after the reflux is complete. That's it for laboratory techniques and operation. I hope you learned a thing or two today. Remember that proper way of setting up and doing these techniques will greatly help you achieving your goal in any experiment.